Hello and welcome to this case study. Today, I'm going to share a case about how Sophus helps a company for international shipment consolidation. Let's turn our focus to House Pro. House Pro is a leading home improvement retailer with a comprehensive network across the U.S., sourcing a diverse range of products from overseas suppliers. Therefore, all their products will be shipped to the ports overseas, put into containers, and finally shipped to the port LA in the U.S. The shipping cost per container is standardized, based solely on the departure and arrival locations, and not by the quantity of goods loaded within. However, each container is subject to capacity constraints, with a maximum of 30 cubic meters and 30,000 kilogram. Optimizing the space by packing as many products as possible, considering their varying sizes and weights, is a crucial business challenge for House Pro in order to minimize freight costs. Moreover, establishing a robust supply chain by identifying alternative suppliers in countries like Vietnam and India is also a key business consideration, especially as they aim to reduce reliance on their current single-source suppliers in China. Before we jump into the model building in Sophus, there are a few key trade-offs for House Pro's business problem, which we need to keep in mind. First, improved container utilization is definitely positive for shipping cost saving, but it might cause other cost increases, like inventory holding cost. Second, inventory management is also an important trade-off. Holding inventory at ports can help to better consolidate, but will cost extra for holding costs. Lastly, supplier selection can also be a trade-off. Chinese suppliers have lower sourcing cost and shipping cost, but might be easily affected by other factors, like trade war. Sourcing from other countries won't have such problems, but the cost will increase. To build this model on Sophus, these are some key input tables. Products table. We need to specify all products' volume and weight for consolidation. Sites table. This table will includes all the suppliers and ports information, customer orders. This table is used to show customer demand for determined throughput level of the network transportation policy table. Show the distance between each node and limit the weight per shipment expression constraint table. Limit the volume per container for shipment consolidation. We will discuss more on next slide about how did we leverage expression constraint, given that a container has specified limits for both volume and weight, and our transportation policy can only enforce one restriction. We have chosen to use an expression constraint to govern the container's volume. An expression constraint establishes a mathematical relationship, as demonstrated on the slide, with 30 representing the volume cap for a single container. Multiplying this by the number of containers yields the total volume capacity. Subtracting the cumulative volume of the goods from this figure, the result must remain above zero to ensure compliance with the volume limitations of the shipment. Okay, after we figure out all the key points of the model, we can start to build out a baseline model. We first built a baseline to reflect House Pro's real network. Sites table defines all the suppliers, ports, and customer, including their address and geocode information. And products table defines the unit weight and volume by product, which is key to work out the container utilization during consolidation. Then customer orders table defines the shipment requirement by customer, product, date, and quantity. And policies tables are the connection between all these sites. We can also define things like cost, shipment size, and inventory. Lastly, expression constraint can be used to enforce some complex conditions. In this case, we use it to limit the max cap volume of each container. After we did all the bullet points on the slide, we should have a decent baseline now. Then we can start to build what-if scenarios to find potential opportunities. We will create 3 scenarios for House Pro. First, optimized baseline, based on the ESA's network, finds the optimized consolidation shipment plans, considering the container capacity limit in both weight and volume. Second, add max dwell time at port, having trade-off between inventory holding cost and shipping cost to find potential business opportunities. The third is the China exit scenario, which only allows no more than 30% of demand from China. Let's examine the results in Sophus's custom BI. We can create bespoke visualizations to suit our model. On the left, we see the baseline scenario without optimization of consolidation, which shows a total cost of $2.2 million and an average container utilization at 74.5%. In scenario 0, Sophus's optimization managed to find $300,000 savings by increasing container utilization to 81%. These savings could be further increased if we allowed additional inventory holding at LA, as shown in scenario 1, where we increased the maximum dwell time allowed for products at the LA port. In the final scenario, we added a hard constraint to force the model to source 70% of materials from outside China. This increased sourcing costs and transportation costs. However, the model was still able to find a shipment plan with good container utilizations. Besides, we can also find the breakdown of all the throughput at each port under different scenarios, which also provides a quick export to Excel for further analysis. Thank you for your attention. If you are interested in exploring Sophus's capabilities further, please don't hesitate to reach out for more information.